In February of 2012, I got a chance to visit the Riga Technical University, the electronics and telecommunications facilities they have there. This is where they house the Latvian Electronic Equipment Testing Center. This is a project of between the University of Riga and the European Union. Here's some equipment under test. This is on audio console. And here they're probing it. They're actually touching the metal parts, probing it with 4 kilovolts at a time. Passed that test okay. This is a test where they actually touched plastic parts with 10 kilovolts. So that probe there is kind of like a stun gun. It has a 10 kilovolts potential on its metal tip there. And they're seeing if it causes...
one there is, what, 8 kilovolts on the probe?
That's it. It said 8. It was actually up to 10 kilovolts. They have to touch buttons over and over again and see if it causes any problem at all when they discharge that or make that 10 kilovolts available there. Next, we moved over to the chamber, the EM chamber. We're going to put the equipment in, turn it on, and point a calibrated antenna at it to read whatever RF products are coming out of the equipment. These are usually caused by clock circuits and switching circuits, especially in CPU-based and DSP-based electronic circuits. And so they're setting the gear up, and they're just about to turn it on. That table that they're setting it up upon actually stands on a turntable. There you can barely see it in the floor. The whole floor is able to turn. The testing that they were doing today was not for final certification. It was just a preliminary test to see, okay, what else about this equipment do we need to take care of? So there's the antenna. Looks like a very specialized, some kind of log periodic antenna. It's accurate over a very wide frequency range, or at least its accuracy is known, its calibration is known. And it connects to a Rohde & Schwarz spectrum analyzer back in the testing room. They can move that antenna up and down on that stand as necessary. There you go. There's the antenna pointing at the equipment that's going to be under test in just a few minutes. We've got to shut the door, leave the room. And when we shut this door, that room is entirely sealed off. You can't hear a radio station, or your cell phone certainly doesn't work in that room. By the way, that's the test equipment room. It also closes up to keep anything out. And there's the seal on the door. You see, it's a very, very good RF radiomagnetic shield with all that finger stock around there. Okay, so here's the computer gear that runs the test equipment. The left-hand screen is talking to a Rohde & Schwarz spectrum analyzer that has a bunch of automatic routines built into it. And the screen in the middle there is a camera in the back to the room. If they were rotating the table on the turntable, then they could see it rotate. And they can also see which polarization the antenna is set to. There's a still photograph of the Rohde & Schwarz spectrum analyzer and a lot of equipment that is associated with it. And here the test goes underway. Today's tests were checking for any emitted radiations between 30 megahertz and 1 gigahertz. So it's going to and the receive bandwidth of the spectrum analyzer, the resolution bandwidth of the spectrum analyzer. These are all fixed items for the test. They know the standards set by the EU for later CE certification. They know what these are, and they're all programmed in the Rohde & Schwarz. So here's the computer output, or what it's displaying, the data that comes from the Rohde & Schwarz spectrum analyzer. And you can see the red line across the top there. That is the don't exceed line for a certain class of certification. After they got done with the first round of tests, they went and rearranged the equipment so as to see, okay, is the spikes that we're getting, is it from one piece of gear or from the cable or from the other piece of gear? And so they were just rearranging the test to get some idea, okay, where do we have to go do the work to reduce the electromagnetic radiation spikes in a few areas. And after hiding one of the pieces of gear from the antenna, well, the spectra is down considerably in most areas, although there still are a spike or two above the red line over on the left. So here's the remote rotation of the antenna. They can turn it from vertical to horizontal polarization and test the gear right there. And they're going to run the whole series of tests over again. once the test is run, the computer actually identifies the places that the peaks that may be over the line and goes and retests those areas with a narrower resolution bandwidth to see if it'll pass the second time. So there we go. That was at the Riga Technical University Electronic and Telecommunications Facility.